So what's the next step? Well, the next step is to do reaction stoichiometry with the ideal gas law. So why don't you take a second while I copy this down and read that problem. We now have a reaction we're doing. So here's what I did. So I took all the information from this word problem, and this is the biggest recommendation I can give you when you get a word problem. Take the information from the word problem and write down the stuff underneath each part of the chemical equation. So what volume of hydrogen gas will be produced when 5.50 grams of aluminum is allowed to react with an excess of hydrochloric acid at 2 atmospheres and a temp of 25 degrees Celsius? So if we look at this, we're looking for a volume of hydrogen. Well, I have P and T. If we think about the ideal gas law, PV equals nRT. We have P, we have T, we're looking for V, R is a constant. I need N. If I can get the moles of hydrogen, then I can solve for the volume of hydrogen. How are we going to get the moles of hydrogen? Reaction stoichiometry. You're going to need to take the 5.50 grams of aluminum over here to moles of hydrogen. Once you then get the moles of hydrogen, then we can plug it into PV equals nRT and solve for V. So let's break it down into those two steps. Step one, can you convert 5.50 grams of aluminum to moles of hydrogen? Give that a shot using a periodic table. You'll need that for the molecular weight of the aluminum. Go ahead. All right. So this first part is just simple stoichiometry. We got to divide by the molar mass of aluminum. And we stop at moles, right? So we go from grams of aluminum to moles of aluminum to moles of hydrogen. And that's exactly what we're looking for right here. So don't keep going to grams. It's not a gram to gram. It's a gram to mole conversion. So 5.5 divided by 26.98 times 3 divided by 2. That would be 0.306 moles. Now that we have everything, again, what I like to do, because the ideal gas law is such a beautiful formula, I'm looking for volume, so I would divide both sides by the pressure. Volume is equal to nRT over P. And now plug it and chug it. Be careful, though. You need to convert that temperature before you plug it in there. Go ahead, I'll give you a minute. All right, so you take 0.306 moles times R, 0.08206 atmospheres times liters over moles times Kelvin times the temperature, 25 degrees Celsius, 298 Kelvin, and the pressure at 2 atmospheres. Moles gone, Kelvin gone, atmospheres gone. We're left with liters, which is great because we're looking for a volume. And you should get 3.74 liters. 3.74 liters as your volume. Yeah, so a little more work with these right problems. So now you have to do some reaction stoichiometry before you can do the ideal gas law. You could also do this in reverse. You could do an ideal gas law to get N and then do some reaction stoichiometry. So the problems kind of take one of two forms.